Geographers, our final topic in weather, El Nino. And for Southern California, El Ninos have affected us in different ways over the years. There seems to be a little bit of media bias towards one thing and not another. So often when there's an announced El Nino coming this winter, you'll see the background graphics for the news channels with heavy rain and discussion of flooding and landslides. Yet, that's not always the case, because for me, I associate El Ninos with drought. In the 1980s, when I was a kid, I'm not going to tell you how old I am. 1980s, we had an extended drought through that period of time for 6 or 7 years, and it was all blamed on an El Nino, and it was very strange for me. That's what I associate with El Ninos because of how it affected me locally. But the truth of the matter is that it's both the images you're seeing here and also not at all, and I'll get to that in just a little bit. So an El Nino is a change in wind and weather patterns over a very large area. So it's primarily we're going to focus on what happens in the Pacific Ocean because that's what's going to affect us, but it actually is a global phenomenon. During normal conditions, we have the trade winds that are blowing from the subtropical high to the ITCZ, and the trade winds blow all the storms, and they also have a current that blows from the east to the west across the Pacific. So the net effect of the normal trade wind conditions is we have heavier storms in the West Pacific. We also have upwelling of cold water. It's replacing the water that's being pushed away from the west coast of the Americas, and that upwelling of cold water means that the cooler water is at a relatively shallower depth. That's in normal conditions. Well, when an El Nino happens, we get the pressure gradient between the subtropical high and the ITCZ weakens. So if the pressure gradient weakens, the winds weaken, so the trade winds aren't as strong, and in some cases we'll actually get a reversal where we get winds blowing out of the west towards the east. And so we no longer are pushing all that water and storms into the western Pacific. So that warm water that had been pushed to the west stays in the eastern Pacific. So we get much more warmer water, less cooler water to replace it, and depending on the strength of the El Nino is we may get a very large area with warm water in it during an El Nino year. So it's basically a reversal. So instead of the storms and warm water being in the western Pacific, the storms and warm water are in the eastern Pacific. Just a quick reminder, we live on the west coast, but we live near the eastern Pacific. So the eastern Pacific is us. So the storms are in this area. That's an El Nino, and it's sometimes called, technically it's the El Nino Southern Oscillation, and so, because this happens every 6 years or so, and we see kind of a variation in the pressure gradient waxing and waning over that period of time. So this is a normal condition. It's not some fluke that's developed recently. It's been ongoing for centuries. It got its name from Peruvian fishermen who noticed that usually the waters changed and the weather changed around Christmas time. So El Nino was the Christ child, and so that's where it got its name from. So here we can see the abnormally warm water areas. So the diagram here, it kind of oversimplifies things because it talks about areas of drought, areas of flooding, but what I like about this is that it shows the global impacts of it. Actually, one of the first people to notice it was a researcher in the early 20th century, and he was looking at the pressure differences between the subtropical high and the ITCZ and how those pressure changes related to when they did and did not have strong summer monsoons that brought rain to India. So he noticed that there was a pattern every 6 or so years with the changing pressure gradient between the subtropical high and the ITCZ. We'll see how just because it's white doesn't mean it's not affected, because we are definitely affected in our areas. Sometimes they're severe, and we can see a pretty substantial rise in sea temperatures creeping up the Southern California coast. This varies. This isn't always going to make it as far north as us. So, by the way, I'll get to a summary page in a little bit, but the results are this is a worldwide shift in weather patterns. And we end up seeing one of the changes that happens is that we don't have as many storms that make it into the Pacific Northwest. And so some of our really bad fires in kind of from San Francisco northward have happened after an El Nino winter because they didn't get their normal rainfall that they would have gotten. So the westerlies actually shift a little bit farther to the north than normal. So the Gulf, they'll get some of the storms. They'll come across the warmer water and then come through here. So they'll go across Mexico like this. So they get a wet Gulf Coast and a Southern California, that who knows? About a third of the time, we get our normal rainfall. Doesn't really affect us. A third of the time, since the storms shift to the north, we don't get any, and we end up with a drought. And then another third of the time, we get some of those storms that go across Mexico, go a little bit farther north than normal, and they'll go across Southern California. And those are the years we'll get really tremendous rainfalls from storms because the water in the Pacific Ocean down and through here is going to be warmer than what we usually get from the mid-latitude cyclones. Since the air is warmer, the water is warmer, the air can hold more moisture. And so when they do get rain from those, they can be much more intense. So for us, Southern California, if somebody tells you next year that we're going to have an El Nino, there's no way of knowing which one of the three we're going to get because it varies for us so much. But we seem to remember that when we do have an El Nino storm, when I say we, I mean the collective of Californians, and that's why they associate it with heavy rains, is that we'll remember those big storms that were an El Nino storm. And we'll tend to forget that the drought was also one of the products of an El Nino. So that was a lot. So all of that for an El Nino is that the normal conditions is that the air moves from the subtropical high to the ITCZ. You already knew that. The trade winds push the ocean currents to the west, and so all the warm water and storms are in the western Pacific over Australia. But the trigger, what starts this whole thing is that pressure gradient varies every few years. And so if the pressure gradient weakens, the winds weakened. And instead of everything being pushed to the west, it stays in the east. And so we get storms in the East Pacific. So it's a reversal of the normal conditions. And for us, since we're right at the edge of this process where it hits the most, sometimes we're hit by it one way, sometimes we're hit by another. So really an El Nino for us, you never know. The opposite, if we do see that pressure gradient variation, sometimes the pressure gradient becomes more intense. And that's referred to as a La Nina. I think they gave up on naming. It's like, what's the opposite of an El Nino? That's it, a La Nina. So if the pressure gradient increases, then we really see strong trade winds pushing much more water, much more storms to the western Pacific. La Ninas are actually a little more consistent for us. If we are having a La Nina, we do have a slightly wetter winter. So that's the only one that's predictable for Southern California is a La Nina. But even at that, it's not all of the time. All right. Thank you, everybody. We'll see you in the next module, which is climate. And in climate, we're looking at long-term averages and what these patterns mean for human habitation, vegetation, agricultural opportunities, all of those factors with climate. Thank you much.